The universe stretches across billions of light years, filled with countless stars, planets, and galaxies, yet here we are, seemingly all alone. This is the Fermi Paradox in a nutshell. If the cosmos is so vast and ancient, where is everyone? The question isn't just a scientific curiosity. It's a profound mystery that challenges our understanding of existence itself. What if we're wrong about being the only intelligent life in the universe? What if somewhere out there civilizations are thriving, evolving, and perhaps even asking the same question about us? The implications of discovering extraterrestrial intelligence would be nothing short of revolutionary, reshaping not only science but our philosophy, culture, and even our place in the cosmos. In this video, we'll explore 20 intricate facts about the possibility of alien life, each one shedding light on this age-old question. From the scientific search for biosignatures on distant exoplanets to the philosophical debates about what it means to be alive, these facts will take you on a journey through the cutting edge of astrobiology, the speculative frontiers of theoretical physics, and the cultural fascination with life beyond Earth. Are we truly alone, or is the universe teeming with other sentient beings? Could we one day make contact, or are we destined to remain isolated? These are the questions that will guide us as we dive into the evidence, the theories, and the enduring mysteries that surround the search for extraterrestrial life. And as we venture into the first fact, consider this. The sheer scale of the cosmos suggests that the odds of us being the only ones might be vanishingly small. So, let's begin our exploration of the universe's greatest enigma, life beyond our pale blue dot. The observable universe is a place of almost unimaginable scale, 93 billion light-years across, filled with over 2 trillion galaxies, each containing hundreds of billions of stars. To put it simply, the numbers are staggering, and with so many stars, each potentially hosting its own family of planets, the idea that Earth is the only planet harboring life seems almost absurd. This is where the Drake equation comes into play, proposed by astrophysicist Frank Drake in 1961. This formula isn't just a mathematical curiosity, it's a framework for thinking about the likelihood of intelligent alien civilizations. The equation takes into account factors like the rate at which stars form, the fraction of those stars with planetary systems, and the number of planets in those systems that could support life. It even considers the probability of life arising and developing the ability to communicate across the cosmos. At its core, the Drake equation is both hopeful and humbling. On one hand, it suggests that the universe could be teeming with civilizations we've yet to encounter. On the other, it reminds us of how many unknowns we still face. For instance, how likely is it that life evolves intelligence? And even if it does, how long do such civilizations last before they disappear? These questions don't have clear answers, which is why the Drake equation sparks such debate. Some scientists see it as a beacon of possibility, while others argue it's too speculative to be useful. But regardless of where you stand, one thing is undeniable. The equation forces us to confront the sheer vastness of the cosmos and our place within it. So, if the universe is so full of potential, why haven't we found any evidence of intelligent life yet? This is the paradox at the heart of our search, and it leads us to the next question. How do we even begin to look for civilizations that might be out there? The answer lies not just in math, but in the tools and techniques we use to scan the skies for signs of life. The search for extraterrestrial intelligence, often referred to as SETI, has been one of humanity's most ambitious scientific endeavors. It all began in 1960 when astronomer Frank Drake pointed a radio telescope in West Virginia toward 2 nearby stars, Tau Ceti and Epsilon Eridani, hoping to catch a whisper of alien communication. This modest experiment, known as Project Ozma, marked the birth of SETI, a mission that continues to captivate scientists and dreamers alike. Over the decades, SETI has evolved from a single experiment into a global effort, using cutting-edge technology to scan the cosmos for any sign of intelligent life. One of the most iconic tools in this search is the Allen Telescope Array, a network of radio dishes nestled in the mountains of Northern California. Funded by Microsoft co-founder Paul Allen, this array is designed to listen for signals across vast swaths of the sky, analyzing frequencies that might carry the fingerprints of alien technology. But it's not alone. Projects like Breakthrough Listen, backed by billionaire Yuri Milner, have expanded the search even further, scanning millions of stars and galaxies for patterns that could indicate intelligent origin. These efforts are like turning on a cosmic radio, tuning in to the faintest whispers of the universe, hoping to hear a voice that isn't human. Yet the search is far from straightforward. The universe is full of natural phenomena, pulsars, quasars, and even the hum of cosmic background radiation that can mimic the kinds of signals we're looking for. Distinguishing between a natural cosmic event and a potential alien transmission is like trying to pick out a single conversation in a crowded stadium. This challenge was highlighted in 1977 when the now famous WOW signal was detected by a radio telescope in Ohio. Lasting just 72 seconds, the signal was so strong and unusual that astronomer Jerry R. Amon circled it on the printout and wrote WOW next to it. Despite decades of searching, the source of the signal remains a mystery, leaving us to wonder: was it a fleeting glimpse of alien intelligence or just a cosmic coincidence? As we continue to scan the skies, the question of what we're actually looking for becomes increasingly important. What forms might alien life take? Could it be something as familiar as carbon-based organisms, or something entirely beyond our imagination? The search for extraterrestrial intelligence isn't just about finding life. It's about expanding our understanding of what life could be. And as we ponder these possibilities, we're reminded that the universe is a place of infinite potential, waiting to reveal its secrets to those who listen closely. While we often imagine alien life as something akin to what we know on Earth, carbon-based organisms thriving in environments filled with water and oxygen, what if life elsewhere looks nothing like us? The idea that all life must follow the same biochemical rules as Earth's is a fascinating assumption, but one that might limit our search for extraterrestrial intelligence. After all, the universe is a place of astonishing diversity, and the chemistry of life could be far more varied than we've ever imagined. This brings us to the possibility of non-carbon-based life, a concept that challenges our understanding of biology and opens up entirely new horizons in the search for alien civilizations. Carbon is often called the building block of life because of its unique ability to form stable, complex molecules, but could other elements play a similar role? Scientists have speculated about alternatives such as silicon-based life. Silicon sits just below carbon on the periodic table, sharing some of its chemical properties. In theory, silicon could form long chains of molecules, much like carbon does, potentially creating the foundation for an entirely different kind of biology. While silicon-based life hasn't been discovered, it's not hard to imagine it thriving in environments where carbon-based organisms couldn't survive, perhaps on scorching planets or in the crushing pressures of gas giants. But silicon isn't the only candidate. Ammonia, for instance, is another intriguing possibility. On Earth, we associate ammonia with cleaning products, but in the right conditions, it could serve as a solvent for life, much like water does for us. Ammonia-based life might flourish in frigid environments, like the icy moons of Jupiter or Saturn, where temperatures are far too cold for liquid water. These speculative biochemistries remind us that life might not need the same ingredients we do, it could find a way to adapt, evolve, and thrive in conditions that seem utterly alien to us. To understand how life might exist in such extreme environments, we can look to Earth's Extremophiles, organisms that survive in conditions once thought impossible. From bacteria thriving in acidic hot springs to microbes living in the crushing depths of the ocean, Extremophiles show us that life is far more resilient and adaptable than we ever imagined. If life on Earth can flourish in such hostile places, why couldn't it do the same elsewhere in the universe? These examples give us hope that life might exist in environments we once dismissed as barren or inhospitable. This shift in perspective doesn't just expand the range of planets we consider habitable, it transforms how we think about the search for alien life. Instead of looking only for Earth-like worlds, we might also turn our attention to places that seem radically different: volcanic moons, frozen oceans, or even the atmospheres of gas giants. By broadening our search parameters, we increase the chances of discovering life in all its possible forms, whether it's carbon-based, silicon-based, or something we haven't even conceived of yet. And as we consider the incredible adaptability of life, we're led to another intriguing question. Could life exist in environments so extreme that they defy our current understanding of biology altogether? This brings us to the next fact, where we'll explore how life might endure in some of the most hostile corners of the cosmos, places where the very laws of physics seem to conspire against it. When we think of life, we often picture lush forests, bustling oceans, or even the familiar ecosystems of our own backyards. But what if life doesn't need these comfortable conditions to thrive? Enter the world of Extremophiles, organisms that defy our expectations by surviving and even flourishing in some of the most inhospitable places on Earth. From the scorching heat of hydrothermal vents at the bottom of the ocean to the acidic pools of Yellowstone, these resilient creatures have rewritten the rulebook on what life can endure. And in doing so, they've opened our eyes to the possibility of life in environments far beyond our planet. Take, for example, the bacteria that live near deep sea vents, where temperatures can soar to over 700 degrees Fahrenheit. These microbes don't rely on sunlight for energy like most life on Earth. Instead, they harness chemicals like hydrogen sulfide, thriving in a process called chemosynthesis. Then there are the tardigrades, often called water bears, which can survive in the vacuum of space, withstand extreme radiation, and even revive after years of dehydration. These tiny, nearly indestructible creatures show us that life is far more adaptable than we ever imagined. But why does this matter in the search for alien life? Because if organisms can survive in such extreme conditions here on Earth, it's entirely possible that life could exist in equally harsh environments elsewhere in the universe. Take Mars, for instance. While its surface may seem barren and lifeless, its subsurface could harbor microbial life, shielded from radiation and potentially sustained by underground water sources. Or consider Europa, one of Jupiter's moons, where a vast, icy ocean lies beneath its frozen crust. The discovery of Extremophiles suggests that life might not only exist in such places but thrive in ways we're only beginning to understand. This shift in perspective has profound implications for astrobiology. Instead of searching only for planets with Earth-like conditions, scientists are now exploring worlds that once seemed too extreme to support life. By studying Extremophiles, we're learning that habitability isn't limited to the narrow range of conditions we once thought necessary. Life, it seems, is far more tenacious and inventive than we gave it credit for. And yet, even as we broaden our search, one question remains central to our understanding of life's potential: the role of water. For all the diversity of Extremophiles, water remains a common thread, a vital ingredient for life as we know it. But could life exist without it? This question leads us to the next fact, where we'll explore the possibility of alternative solvents and how they might redefine our search for life in the cosmos. Because if life can adapt to such extremes, perhaps it can also find ways to thrive without the one thing we've always considered essential. Water is often called the universal solvent, and for good reason. It's the foundation of life as we know it. Every cell in your body relies on water to function, from transporting nutrients to facilitating chemical reactions. On Earth, where water is abundant, this makes perfect sense. But what about the rest of the universe? Is water essential for all life, or could other substances play the same role? This is the heart of the water paradox, a question that sits at the crossroads of biology, chemistry, and astrobiology. Water is undeniably widespread in the cosmos. It's been found on the Moon, Mars, and even in the atmospheres of distant exoplanets. Some of the most exciting discoveries in recent years involve icy moons like Europa and Enceladus, where vast oceans are thought to lie beneath their frozen surfaces. Europa, one of Jupiter's largest moons, is believed to have a subsurface ocean twice the volume of all Earth's oceans combined. Enceladus, a small moon of Saturn, spews water vapor and ice particles into space from geysers at its south pole. These findings suggest that water, and perhaps the conditions for life, might be far more common in the universe than we once thought. But here's the twist: while water is abundant, it's not the only solvent capable of supporting life. Scientists have theorized about alternatives like methane and ammonia, which could serve as the basis for entirely different biochemistries. For instance, on Titan, Saturn's largest moon, rivers and lakes of liquid methane dot the landscape. In such an environment, methane could play a role similar to water, dissolving nutrients and facilitating chemical reactions necessary for life. Ammonia, with its ability to remain liquid at much lower temperatures, is another intriguing candidate. It could support life in frigid environments where water would freeze solid, opening up possibilities for life on distant, icy worlds. The idea of alternative solvents challenges our Earth-centric view of biology. It forces us to ask, is water truly indispensable, or is it just one of many possible foundations for life? This question becomes even more compelling when we consider the diversity of environments in the universe. From scorching exoplanets to frozen moons, the potential for life to adapt and thrive in unexpected ways is immense. And as we expand our understanding of what life could look like, we also expand the scope of our search. But this leads us to an even deeper question: how does life begin in the first place? Whether it's water-based, methane-based, or something entirely different, the origins of life remain one of science's greatest mysteries. What conditions are necessary for the spark of life to ignite, and how likely is it that this process has happened elsewhere in the universe? These are the questions that will guide us as we move into the next fact, where we'll explore the fascinating theories about life's origins and what they might mean for the existence of life beyond Earth. The story of life's origins is one of the most profound mysteries in science. How did something as complex as life emerge from the simplicity of non-living matter? This process, known as abiogenesis, lies at the heart of our understanding of life, not just on Earth but potentially elsewhere in the universe. Abiogenesis suggests that under the right conditions, the building blocks of life can spontaneously form, setting the stage for the emergence of living organisms. But what exactly are those conditions, and how likely are they to exist elsewhere? One of the most famous experiments exploring this idea is the Miller-Urey Experiment, conducted in 1953. Chemists Stanley Miller and Harold Urey recreated the conditions thought to exist on early Earth, combining water, methane, ammonia, and hydrogen in a sealed apparatus. They then introduced electrical sparks to simulate lightning, a common occurrence on our young planet. Within days, the experiment produced something remarkable: amino acids, the fundamental building blocks of proteins and, by extension, life itself. This groundbreaking study showed that the ingredients for life could arise naturally from simple chemical reactions, suggesting that the universe might be primed for life in ways we're only beginning to understand. But the Miller-Urey experiment is just one piece of the puzzle. Scientists have since discovered that amino acids can form in space, found in meteorites and even in the clouds of gas surrounding distant stars. These findings hint that the raw materials for life might be scattered throughout the cosmos, waiting for the right conditions to spark the emergence of living organisms. The question then becomes, how common are those conditions? Could other planets, moons, or even interstellar environments provide the necessary ingredients and energy for life to begin? This brings us to the potential for abiogenesis beyond Earth. Take Mars, for example. Once thought to be a barren desert, evidence now suggests that the red planet may have had water, and possibly even oceans billions of years ago. If Mars once had the right conditions for life to emerge, could remnants of that life still exist beneath its surface? Or consider Europa and Enceladus, icy moons with subsurface oceans that might harbor the chemical soup needed for life. These environments, though radically different from Earth, could still provide the right combination of water, energy, and organic compounds to kickstart life. The search for life in our solar system isn't just about finding organisms, it's about uncovering the universal principles that govern the emergence of life. If we can identify the processes that led to life on Earth, we might gain insights into where and how life could arise elsewhere. This quest is as much about understanding our own origins as it is about exploring the cosmos. But the story doesn't end with abiogenesis. The emergence of life is only the beginning. Once life begins, it must survive, adapt, and evolve, a process that raises even more questions. What environmental factors are necessary for life to thrive over billions of years? And how does life transition from simple microbes to complex, intelligent beings? These are the questions that will guide us as we move into the next fact, where we'll explore the conditions that make a planet not just habitable but capable of sustaining life over cosmic timescales. Because the journey from non-living matter to sentient beings is a story that's still being written not just here on Earth, but perhaps on countless worlds across the universe. Mars has long captured our imagination as the most Earth-like planet in our solar system. Its reddish hue, polar ice caps, and vast, dusty plains have made it a focal point in our search for extraterrestrial life. But beyond its striking appearance, Mars holds secrets that could rewrite our understanding of life's potential in the cosmos. For decades, scientists have probed its surface and atmosphere, searching for clues that might reveal whether the red planet was ever home to living organisms, or if it still is today. This quest has taken us from the early Viking missions of the 1970s to the cutting-edge explorations of the Perseverance rover, and the discoveries along the way have been nothing short of astonishing. One of the most significant breakthroughs came with the discovery of liquid water beneath Mars' surface. Using radar data from the European Space Agency's Mars Express orbiter, scientists detected a massive underground lake near the planet's south pole in 2018. This body of water, buried beneath a mile of ice, spans roughly 12 miles across and suggests that Mars may still have the conditions necessary to support microbial life. Water, as we know, is essential for life as we understand it, and its presence on Mars, even in hidden, icy reservoirs, opens up thrilling possibilities. Could tiny, resilient organisms be thriving in these dark, briny depths? Much like extremophiles do in Earth's harshest environments, the search for life on Mars hasn't been without its challenges. The Viking missions of the 1970s were the first to directly test for signs of life, conducting experiments designed to detect biological activity in the Martian soil. While some results initially seemed promising, the findings were ultimately inconclusive, leaving scientists to debate whether the reactions observed were truly biological or simply the result of unusual chemical processes. This ambiguity highlights one of the greatest hurdles in astrobiology: how to definitively confirm the presence of life, especially when it might look nothing like what we're familiar with. Fast forward to today, and the Perseverance rover is carrying on this legacy with state-of-the-art tools designed to search for biosignatures, chemical or physical traces of past or present life. Since landing in Jezero crater in 2021, Perseverance has been analyzing rocks and soil, collecting samples that could one day be returned to Earth for further study. Jezero crater, once the site of an ancient lake, is a prime location for uncovering evidence of microbial life that might have existed billions of years ago, when Mars was warmer and wetter. The rover's discoveries so far, including organic molecules and intriguing mineral formations, have only deepened the mystery and excitement surrounding Mars' potential to harbor life. But even as we uncover more about Mars, the challenges of confirming extraterrestrial life remain daunting. The harsh radiation, thin atmosphere, and extreme temperatures on the planet's surface make it a difficult place for life to survive, but not necessarily impossible. Underground, shielded from the brutal conditions above, microbial life could still persist, waiting to be discovered by future missions. These missions, like the planned Mars Sample Return campaign, aim to bring Martian soil and rock samples back to Earth, where they can be analyzed with tools far more advanced than anything we can send to the Red Planet. Such efforts could finally provide the answers we've been searching for. As we continue to unravel the mysteries of Mars, our gaze also turns to other worlds that might hold the keys to understanding life's potential in the universe. Among these are the icy moons of Jupiter and Saturn, places like Europa and Enceladus, where vast oceans slosh beneath frozen crusts, offering environments that could be just as promising as Mars for harboring life. These distant moons remind us that the search for extraterrestrial life isn't confined to planets alone. The universe is full of surprises, and the next great discovery could come from the most unexpected places. Europa and Enceladus are two of the most tantalizing targets in our solar system when it comes to the search for extraterrestrial life. These moons, orbiting Jupiter and Saturn respectively, are more than just frozen rocks in space. They're worlds with hidden oceans locked beneath thick layers of ice. Europa, slightly smaller than Earth's moon, has long fascinated scientists with its smooth, icy surface crisscrossed by reddish-brown fractures. These cracks hint at a dynamic interior where a subsurface ocean might be churning, kept liquid by the gravitational tug of war from Jupiter. Enceladus, on the other hand, is a tiny moon with a big secret. It spews plumes of water vapor and ice particles into space from geysers near its south pole, offering a direct glimpse of the ocean beneath its frozen shell. The discovery of these subsurface oceans has revolutionized our understanding of where life might exist in the universe. On Earth, life thrives in some of the most extreme environments, from the sunless depths of the ocean to the acidic waters of volcanic hot springs. Hydrothermal vents, in particular, are hotspots for microbial ecosystems, teeming with life that relies not on sunlight but on chemical energy from the Earth's interior. Scientists suspect that similar hydrothermal activity could be occurring on Europa and Enceladus, driven by the tidal forces of their massive parent planets. If that's the case, these moons could host microbial communities thriving in the dark, warm waters beneath their icy crusts. But how do we know these oceans exist in the first place? For Europa, the evidence comes from observations made by NASA's Galileo spacecraft, which orbited Jupiter in the late 1990s. Galileo detected a magnetic field around Europa, suggesting the presence of a conductive layer beneath its surface, most likely a salty ocean. Enceladus, meanwhile, revealed its secrets through the Cassini mission, which flew through the moon's icy plumes and analyzed their composition. Cassini found organic molecules, tiny grains of silica, and even molecular hydrogen, all signs of hydrothermal activity and potential ingredients for life. Despite the promising evidence, exploring these distant oceans is no small feat. The ice shells covering Europa and Enceladus are thought to be miles thick, presenting a formidable barrier to any mission aiming to reach the liquid water below. Scientists are working on innovative solutions such as ice-penetrating probes and robotic submarines, but the technological challenges are immense. Radiation from Jupiter poses another hurdle, as it could damage sensitive instruments and make long-term exploration of Europa particularly difficult. Yet the potential rewards are worth the effort. Discovering life, or even the conditions for life on these moons, would be a monumental leap forward in our understanding of biology and our place in the cosmos. As we contemplate the mysteries of Europa and Enceladus, our gaze naturally extends beyond our solar system to the countless exoplanets orbiting distant stars. If moons in our own backyard could harbor life, what might lie on worlds light years away? This shift in perspective brings us to the next fact, where we'll explore how the discovery of exoplanets has transformed our search for extraterrestrial intelligence and opened up new possibilities for finding life in the universe. After all, the cosmos is vast, and the search for life is just beginning. The search for life beyond our solar system has taken a giant leap forward with the discovery of exoplanets' worlds orbiting distant stars. Among these discoveries, one concept has become central to the hunt for habitable worlds: the Goldilocks zone. Also known as the habitable zone, this is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold like the porridge in the fairy tale, it's just right. This zone is crucial because, as far as we know, liquid water is essential for life as we understand it. And with thousands of exoplanets now identified, the possibilities for finding life in these regions are more exciting than ever. Take, for example, Proxima Centauri b, the closest known exoplanet to Earth at just over 4 light-years away. Orbiting within the habitable zone of its red dwarf star, this rocky world has sparked intense interest. Could it have the right conditions to support life? Scientists are eager to find out, but there's a catch. Red dwarf stars are known for their violent stellar activity, bombarding nearby planets with radiation. While Proxima Centauri b may lie in the Goldilocks zone, its atmosphere, if it has one, would need to withstand these harsh conditions to make it truly habitable. Another fascinating system is TRAPPIST-1, a star about 40 light-years away that hosts 7 Earth-sized planets. 3 of these worlds, TRAPPIST-1e, F, and G, sit snugly within the habitable zone, raising hopes that they might have liquid water and potentially life. What makes this system even more intriguing is the close proximity of the planets to one another. If you stood on one of these worlds, you might see neighboring planets hanging in the sky like glowing orbs, a sight that would make our own moon pale in comparison. But the question remains, could life thrive in such a tightly packed system? Finding these distant worlds is no small feat. Scientists rely on ingenious methods to detect exoplanets, often without ever seeing them directly. One of the most successful techniques is the transit method, which measures the slight dimming of a star's light as a planet passes in front of it. This method has allowed us to discover thousands of exoplanets, including many in the habitable zone. Another approach, called radial velocity, detects the subtle wobble of a star caused by the gravitational pull of an orbiting planet. Together, these methods have opened up a new frontier in our understanding of the cosmos, revealing a universe teeming with potential. But the discovery of exoplanets is only the beginning. As we identify more worlds in the Goldilocks zone, the next step is to determine whether they could support not just life but intelligent life. This brings us to the heart of the matter. What conditions are necessary for a civilization to arise and thrive? The answer to this question could shape the future of our search for extraterrestrial intelligence, guiding us toward the most promising targets in the vast expanse of space. As we continue to explore these distant worlds, one thing is clear: the universe is full of surprises, from the scorching deserts of Proxima Centauri b to the icy realms of TRAPPIST-1e. Each discovery challenges our assumptions and expands our understanding of what's possible. And as we venture deeper into the cosmos, we're reminded that the search for life isn't just about finding answers, it's about asking the right questions. What might life look like on a planet orbiting a red dwarf star? Could civilizations flourish in systems with multiple habitable worlds? These are the mysteries that drive us forward, pushing the boundaries of science and imagination alike. While the discovery of exoplanets has opened up a universe of possibilities, it also brings us face to face with a profound question. If the cosmos is so vast and ancient, why haven't we encountered any signs of intelligent life? This mystery is at the heart of what's known as the Great Filter Hypothesis, a theory that suggests there may be an almost insurmountable barrier preventing civilizations from reaching a stage where they can communicate across the stars. But what exactly is this filter, and could it hold the key to understanding whether we're destined to thrive or vanish as a species? The idea of the Great Filter was first popularized by economist Robin Hanson in the late 1990s, and it's as intriguing as it is unsettling. The hypothesis proposes that somewhere along the evolutionary path from simple molecules to spacefaring civilizations, there's a critical step, a filter, that's incredibly difficult to pass. This filter could lie in our past, meaning that the emergence of intelligent life is so rare that we're among the lucky few who made it through. Alternatively, it could lie in our future, suggesting that civilizations inevitably face a catastrophic event that prevents them from surviving long enough to explore the cosmos. If the filter is behind us, it's a reason to celebrate. It would mean that the odds of life evolving into intelligent, technologically advanced beings are astronomically low, and we've already overcome the greatest hurdle. But if the filter lies ahead, the implications are far more sobering. It could mean that civilizations like ours inevitably self-destruct, whether through war, environmental collapse, or some other existential threat. Or perhaps there's a universal challenge, like the development of artificial intelligence or the discovery of destructive technologies, that no civilization can survive. This idea isn't just speculative, it's deeply tied to the Fermi Paradox. If intelligent life is common, we should see evidence of it everywhere, but we don't. So, is the Great Filter the reason why? If so, where does it sit on the timeline of a civilization's existence, and what does that mean for humanity? These questions aren't just academic, they're existential. The Great Filter forces us to confront the fragility of our own civilization and the choices we make as we advance technologically and socially. But here's the twist: the Great Filter isn't just about doom and gloom. It's also a call to action. If the filter lies in our future, we have the power to change our trajectory. By addressing global challenges like climate change, nuclear proliferation, and the ethical use of technology, we might just be able to navigate around the filter and secure our place in the cosmos. This perspective transforms the Great Filter from a source of fear into a catalyst for hope, a reminder that our future is still ours to shape. As we ponder the implications of the Great Filter, another intriguing possibility emerges. What if the filter doesn't apply to us at all? What if ancient alien civilizations once thrived in the universe, only to vanish long before we arrived on the scene? This idea leads us into the next fact, where we'll explore the tantalizing evidence and theories surrounding ancient alien civilizations and what they might tell us about the fate of intelligent life in the cosmos. Because if we're not alone, the echoes of those who came before us might still be out there waiting to be discovered. What if humanity isn't the first advanced civilization to walk this planet? It's a bold idea, but one that's gaining traction in scientific circles thanks to the Silurian hypothesis, named after the reptilian humanoids from a classic episode of Doctor Who. This hypothesis suggests that Earth may have hosted intelligent, technologically advanced species long before humans ever appeared. The concept isn't just a thought experiment, it's a serious attempt to grapple with the question of how we might detect ancient civilizations, whether on Earth or elsewhere in the universe. If advanced life existed here millions of years ago, could we even find evidence of it today? And what would that mean for our search for alien life on other planets? The Silurian hypothesis hinges on a simple but profound question: how long does the evidence of a civilization last? On Earth, the geological record preserves traces of life going back billions of years: fossils, chemical signatures, and even the faint remnants of ancient ecosystems. But what about the artifacts of a civilization? Cities, machines, and technology are far more fragile than bones or shells. Over millions of years, erosion, plate tectonics, and natural decay would erase most traces of a civilization's existence. Even materials like plastic and metal, which we consider durable, would eventually break down or be buried so deeply that they'd be nearly impossible to detect. This raises a startling possibility. If an ancient civilization thrived on Earth, say 100 million years ago, would we even know? To explore this idea, scientists have looked to Earth's own geological history for clues. One key challenge is distinguishing between natural processes and artificial ones. For example, certain chemical signatures in rocks or sediments could indicate industrial activity, but they might also be the product of volcanic eruptions or other natural phenomena. Similarly, unusual patterns in the fossil record could hint at the presence of a civilization, but proving it would require extraordinary evidence. The Silurian hypothesis doesn't claim that such a civilization existed, only that if it did, we might struggle to find definitive proof. This uncertainty forces us to rethink how we search for signs of intelligence, not just on Earth but across the cosmos. The implications of this hypothesis stretch far beyond our own planet. If advanced civilizations can rise and fall without leaving clear traces, what does that mean for our search for alien life? On distant worlds where geological processes might differ from Earth's, the evidence of past civilizations could be even harder to detect. This raises an unsettling possibility. We might be surrounded by the remnants of ancient galactic civilizations, their cities and technologies long since reduced to dust. Without a way to distinguish their ruins from natural formations, we could be missing the very evidence we're searching for. But here's the twist: technology might be the key to unlocking this mystery. As our tools for exploring the cosmos grow more sophisticated, so too does our ability to detect subtle signs of intelligence. From advanced telescopes capable of spotting artificial structures on distant planets to AI algorithms that can sift through vast amounts of data for patterns, the search for ancient civilizations both on Earth and beyond is entering a new era. These technologies don't just help us look for life, they help us redefine what life might look like. And as we push the boundaries of what's possible, we're reminded that the universe is full of surprises waiting for us to uncover them. This brings us to a fascinating question. What role does technology play in our search for alien life? From radio telescopes to space probes, our tools shape not only what we find but how we understand the cosmos. And as we continue to innovate, we might just discover that the answers we're seeking have been hiding in plain sight all along. Imagine looking up at the night sky and spotting a star that flickers in a way no natural object ever should. What if that unusual pattern wasn't caused by a cosmic phenomenon, but by something far more extraordinary, a vast artificial structure built by an advanced alien civilization? This is the tantalizing idea behind technosignatures, the telltale signs of technology that could reveal the presence of intelligent life beyond Earth. Unlike biosignatures, which hint at the existence of life itself, technosignatures point to the work of civilizations capable of altering their environment on a cosmic scale. From megastructures orbiting distant stars to artificial light illuminating alien cities, technosignatures offer a way to search for intelligence that's as creative as it is scientific. One of the most famous examples of a technosignature is the Dyson sphere, a hypothetical megastructure first proposed by physicist Freeman Dyson in 1960. The idea is simple yet mind-blowing. An advanced civilization might build a vast shell or swarm of satellites around its star to capture its energy output, harnessing the power of an entire sun. From Earth, such a structure would appear as a star that dims in unusual ways or emits infrared radiation as the captured energy is re-radiated as heat. While no definitive Dyson spheres have been found yet, astronomers have identified a handful of stars with puzzling behavior, like Tabby's star, whose irregular dimming has sparked intense speculation about whether it could be surrounded by artificial constructs. But Dyson spheres are just the beginning. Technosignatures could take many forms, from massive orbital habitats to artificial light sources on the surfaces of distant planets. Imagine a civilization that has mastered the art of redirecting sunlight to illuminate its cities during the night. Such a feat might be detectable as an unnatural glow on the dark side of an exoplanet. Or consider the possibility of communication lasers, powerful beams of light used to send messages across the cosmos. These signals, if aimed in our direction, might stand out against the background noise of the universe, offering a clear sign of intelligence at work. Detecting these technosignatures requires a blend of ingenuity and cutting-edge technology. Telescopes like the James Webb Space Telescope, with its ability to analyze the atmospheres of distant planets, could play a key role in spotting anomalous patterns of light or heat. Radio telescopes, already used in the search for extraterrestrial intelligence, might pick up signals from advanced civilizations transmitting across the stars. And as our tools become more sophisticated, so too does our ability to sift through the vast amounts of data collected by these instruments, searching for the faintest hints of alien technology. Yet, as exciting as the search for technosignatures is, it also raises profound questions about what it means to make contact with an alien civilization. If we were to detect a Dyson sphere or receive a signal from a distant star, how should we respond? The ethical implications of such a discovery are immense. Should we attempt to communicate, risking the possibility of misunderstanding or even conflict? Or would it be wiser to observe quietly, learning all we can without revealing our presence? These are the kinds of questions that challenge not only our scientific understanding but our philosophical and moral frameworks as well. As we peer into the cosmos, searching for the faint glimmers of alien technology, we're reminded that the universe is full of possibilities. Technosignatures offer a window into the ingenuity of civilizations far beyond our own, but they also force us to confront the responsibilities that come with discovery. And as we ponder these questions, another layer of the mystery unfolds. What happens if we're not just searching for alien life, but actively trying to communicate with it? This brings us to the next fact, where we'll explore the fascinating world of interstellar messaging and the risks and rewards of reaching out to the stars. The idea of making contact with an alien civilization is one of the most thrilling and daunting prospects in the search for extraterrestrial intelligence. But what happens if we succeed? What if one day we receive a message from the stars, or worse, a spacecraft arrives in our solar system? The ethical dilemmas surrounding first contact are as complex as they are fascinating, forcing us to confront questions that go far beyond science and into the realms of morality, culture, and even survival. On one hand, the benefits of contact could be extraordinary. Imagine the exchange of knowledge between civilizations separated by thousands or even millions of years of evolution. An advanced alien society might share breakthroughs in medicine, energy, or technology that could transform life on Earth. They could offer insights into the nature of the universe, solving mysteries that have puzzled humanity for centuries. The cultural exchange alone would be monumental, challenging our understanding of art, philosophy, and what it means to be alive. The potential for growth and discovery is almost limitless. But with these possibilities come significant risks. What if the intentions of an alien civilization are not peaceful? History is full of examples of less advanced societies being exploited or destroyed by more powerful ones. Could we be risking our own survival by reaching out? Even if the aliens are benevolent, the mere act of contact could have unintended consequences. Their technology or biology might inadvertently harm us, or their ideas could disrupt our societies in ways we can't predict. The stakes couldn't be higher, which is why protocols like METI, messaging extraterrestrial intelligence, exist to guide how we might communicate with potential alien neighbors. METI advocates for a cautious, deliberate approach to sending messages into space, emphasizing the need for international collaboration and ethical consideration. But not everyone agrees. Some scientists argue that actively trying to contact aliens is reckless, likening it to shouting into a dark forest without knowing what's out there. Others believe that the potential rewards outweigh the risks, and that humanity has a responsibility to reach out and connect with the cosmos. This debate highlights a fundamental tension: the desire to explore and learn versus the need to protect ourselves from the unknown. Beyond the practical concerns, first contact also raises profound philosophical questions. What rights would an alien civilization have, and how would we ensure they're treated with respect? Would we impose our own moral frameworks on them, or would we need to develop entirely new ethical systems to navigate the complexities of interstellar relations? These questions don't have easy answers, but they force us to think deeply about our place in the universe and the responsibilities that come with being part of a larger cosmic community. This intersection of science and philosophy brings us to another layer of the search for alien life: the role of religion and belief systems. How would humanity's diverse spiritual traditions react to the discovery of extraterrestrial intelligence? Would it challenge our understanding of creation, divinity, and the purpose of life? Or could it enrich our spiritual perspectives, offering new ways to see ourselves in the grand tapestry of the cosmos? These questions remind us that the search for alien life isn't just a scientific endeavor. It's a deeply human one, touching on the very essence of who we are and what we believe. As we grapple with these ethical and philosophical questions, another intriguing possibility emerges. What if the search for alien life isn't just about finding others, but about understanding ourselves? This idea leads us into the next fact, where we'll explore how the pursuit of extraterrestrial intelligence has shaped our own culture, art, and collective imagination. Because in looking to the stars, we might just discover something profound about the human spirit. For thousands of years, humanity's understanding of existence has been shaped by religion and philosophy, systems of thought that seek to explain our origins, purpose, and place in the cosmos. But what happens if we discover that we're not alone? The revelation of extraterrestrial life wouldn't just be a scientific milestone. It would challenge the very foundations of how we see ourselves in the universe. From ancient myths to modern theology, the idea of life beyond Earth has always sparked profound questions about creation, divinity, and the nature of existence. And as we stand on the brink of potentially answering one of humanity's oldest questions, we must also ask, how would our beliefs adapt to such a discovery? Historically, many cultures have entertained the possibility of life beyond Earth, often weaving it into their spiritual and mythological traditions. Ancient Hindu texts, for example, describe multiple worlds and realms inhabited by divine beings, while the Dogon people of Mali have long spoken of extraterrestrial visitors who shared knowledge with their ancestors. Even in the Judeo-Christian tradition, some theologians have speculated whether other worlds might exist within God's creation. These ideas, though often symbolic, reflect a universal curiosity about our place in the cosmos, a curiosity that continues to shape how we grapple with the possibility of alien life today. Modern theology has taken this curiosity even further, with some religious thinkers proposing that the discovery of extraterrestrial intelligence could coexist with or even enrich existing beliefs. For instance, the Catholic Church has openly discussed the idea of life on other planets, with Pope Francis suggesting that such a discovery wouldn't contradict the teachings of Christianity. Similarly, Islamic scholars have explored how the Quran's descriptions of creation might accommodate the existence of beings beyond Earth. These perspectives highlight a willingness to adapt and reinterpret ancient texts in light of new discoveries, suggesting that faith and science might not be as opposed as they sometimes seem. But not all reactions would be so harmonious. For some, the discovery of alien life could upend deeply held beliefs, creating a crisis of faith that shakes the foundations of religion. If life exists elsewhere, what does that mean for humanity's unique relationship with the divine? Are we still the center of creation, or just one thread in a vast cosmic tapestry? These questions don't have easy answers, but they force us to confront the possibility that our understanding of the universe and our place within it might be far more limited than we've ever imagined. Philosophers, too, have grappled with these questions for centuries, from the ancient Greeks who speculated about life on the moon to Enlightenment thinkers like Immanuel Kant, who pondered the ethical implications of encountering alien beings. The search for extraterrestrial intelligence has always been intertwined with philosophical inquiry. Today, these debates continue, with modern philosophers exploring how the discovery of alien life might challenge our concepts of morality, identity, and even what it means to be human. If we're not alone, does that diminish our significance, or does it expand our sense of connection to a universe teeming with possibilities? As we navigate these complex questions, one thing becomes clear: the search for alien life isn't just about finding answers, it's about understanding ourselves. It forces us to confront our assumptions, adapt our beliefs, and imagine new possibilities for what life could be. And as we ponder these profound implications, our gaze turns to the cosmos, where life might exist in the most unexpected places. From the icy moons of our solar system to the distant exoplanets orbiting alien suns, the universe is full of surprises, waiting to challenge our understanding of life, faith, and our place in the grand cosmic story. Among the countless planets in our universe, some are not bound to stars at all. These are rogue planets, lonely worlds drifting through the cold, dark void of space, untethered from any solar system. Imagine a planet, perhaps larger than Earth, wandering endlessly through the cosmos, its surface shrouded in perpetual night. It sounds like something out of science fiction, but rogue planets are very real. Astronomers estimate there could be billions of them in our galaxy alone, ejected from their original star systems during the chaotic early days of planetary formation. But here's the fascinating question: could these wandering worlds harbor life? At first glance, the idea seems far-fetched. Without a star to provide warmth and light, how could life survive? But nature is full of surprises. On Earth, we've discovered ecosystems thriving in the most unlikely places deep beneath the ocean floor, where sunlight never reaches, or in the scorching heat of volcanic vents. These environments rely not on sunlight but on geothermal energy, the heat generated by the planet's interior. Could rogue planets with their own internal heat sources host similar ecosystems? It's not impossible. If a rogue planet has a molten core and enough geothermal activity, it might create pockets of warmth beneath its icy surface, offering a refuge for microbial life or perhaps even more complex organisms. The challenges of detecting rogue planets, however, are immense. Unlike planets that orbit stars, these wanderers emit no light of their own, and they're often too far from any star to be illuminated. Traditional methods of planet detection, like observing the dimming of a star's light or measuring its gravitational wobble, don't work for rogue planets. Instead, astronomers rely on a technique called gravitational microlensing, where the gravity of a rogue planet bends and magnifies the light from a distant star, briefly revealing its presence. Even so, these events are rare and fleeting, making rogue planets some of the most elusive objects in the universe. Studying these worlds is no easier. Without a nearby star to provide energy, any mission to a rogue planet would face extraordinary hurdles. Spacecraft would need to rely on nuclear power or other long-lasting energy sources, and the journey itself could take centuries. Yet, the possibility of discovering life on a rogue planet is so tantalizing that scientists are already brainstorming ways to make it happen. One idea involves sending probes equipped with advanced AI to navigate the vast distances and harsh conditions, searching for signs of life where no human could ever go. But here's another intriguing angle. What if rogue planets aren't just accidental wanderers? Some theories suggest that these worlds could have been intentionally ejected from their star systems by advanced civilizations, perhaps as a way to preserve life during a cosmic catastrophe. If true, rogue planets might not just be accidental survivors, they could be cosmic arcs carrying the seeds of life across the galaxy. This idea, while speculative, adds another layer of mystery to these enigmatic worlds. As we ponder the possibilities of life on rogue planets, another question comes to mind. How much time do we have to find it? The universe is unimaginably vast, and our search for alien life is constrained not just by distance but by the sheer scale of cosmic time. Civilizations might rise and fall long before we ever detect them, their signals lost in the void. This leads us to the next fact, where we'll explore the role of time in the search for extraterrestrial intelligence and whether our quest might be a race against the clock. Because in a universe as ancient and dynamic as ours, timing might be everything. The universe operates on a timescale that's almost impossible for us to fully grasp. Billions of years stretch between the birth and death of stars, and civilizations, if they exist, could rise, thrive, and vanish in the blink of a cosmic eye. When we search for alien life, we're not just looking across unimaginable distances, we're also racing against time itself. The history of the universe spans over 13 billion years, and the odds that another intelligent species exists right now at the same moment as us are staggeringly slim. This is the challenge of synchronizing our existence with other civilizations, a problem that lies at the heart of the search for extraterrestrial intelligence. Consider this: the Milky Way alone is over 13 billion years old. If intelligent life emerged on another planet just a million years before or after us, we might miss each other entirely. A million years might seem like an eternity to us, but on a cosmic scale, it's no more than a fleeting moment. Civilizations could have flourished during the era of the dinosaurs, only to disappear long before humans ever walked the Earth. Or they might emerge millions of years from now, long after our own civilization has faded into history. The vastness of time means that even if the universe is teeming with life, we might never overlap with another intelligent species. This raises a tantalizing possibility. What if we're not searching for living civilizations but for their remnants? Just as archaeologists unearth the ruins of ancient human societies, could we one day discover the artifacts of long-dead alien civilizations? Imagine finding the skeletal remains of a Dyson sphere orbiting a distant star, or stumbling upon a derelict spacecraft drifting through the void. These relics would offer a glimpse into the lives and deaths of civilizations that once thrived in the cosmos, but detecting such remnants is no easy task. Over millions or billions of years, even the most durable structures would erode, decay, or be buried beneath layers of cosmic dust. The search for ancient alien civilizations is a race not just against time, but against the relentless forces of entropy. Even more intriguing is the idea that we might be looking in the wrong universe altogether. What if intelligent life exists not just in our universe, but in others? This brings us to the concept of parallel universes, a theory that suggests our universe might be just one of countless others, each with its own unique set of physical laws and possibilities. In some of these universes, the conditions for life might be far more common, or civilizations might have evolved in ways we can't even imagine. While the idea of parallel universes remains speculative, it opens up a mind-bending new frontier in the search for alien life. If we can't find life in our own universe, perhaps we need to look beyond it. As we ponder these vast timescales and parallel realities, one thing becomes clear: the search for alien life is as much about understanding time as it is about understanding space. It forces us to confront the fleeting nature of existence and the immense scale of the cosmos. And as we turn our gaze to the stars, we're reminded that the answers we seek might not lie in the present, but in the echoes of civilizations long gone, or in universes we've yet to discover. This brings us to the next fact, where we'll explore how the concept of parallel universes could redefine not just our search for life, but our understanding of reality itself. What if our universe is just one of countless others, each with its own unique set of rules and possibilities? This is the fascinating idea behind the multiverse theory, a concept that not only challenges our understanding of reality, but also opens up extraordinary possibilities for the existence of alien life. Imagine a cosmos where the laws of physics aren't fixed, where gravity might be stronger, light could travel faster, or time itself flows differently. In such a multiverse, life could take forms and inhabit environments that are utterly unimaginable to us. Could there be civilizations thriving in universes where the very fabric of existence operates under entirely different principles? The answer, according to multiverse theory, might be a resounding yes. The multiverse theory isn't just science fiction. It's a serious scientific idea with roots in quantum mechanics, cosmology, and string theory. Some versions of the theory suggest that every possible outcome of every event creates a new universe, branching off into infinite realities. Others propose that our universe is just one bubble in a vast cosmic foam, with other bubbles existing alongside ours, each governed by its own physical laws. While these ideas remain speculative, they offer a tantalizing framework for thinking about life beyond our universe. If life can emerge in a universe with our specific laws, why not in others? In a multiverse, the possibilities are truly endless, but here's the catch: testing the multiverse theory is no easy task, because these parallel universes, if they exist, would operate under different physical laws. They might be entirely inaccessible to us. We can't travel to them, observe them, or even detect them directly. This makes the multiverse one of the most challenging ideas in science to prove or disprove. Yet, despite these hurdles, the theory continues to captivate scientists and philosophers alike. not least because it reshapes how we think about the search for alien life. If life can exist in universes with radically different conditions, then the potential for extraterrestrial intelligence becomes even more vast and varied than we've ever imagined. This idea also forces us to reconsider what we mean by life. In a universe where the laws of physics are different, life might not rely on carbon, water, or even chemistry as we know it. It could be based on entirely different principles existing in forms that defy our current understanding of biology. For example, in a universe where gravity is weaker, life might evolve to float effortlessly through the air, or in a universe where time flows erratically, life might adapt to exist in fleeting moments. The multiverse theory doesn't just expand the search for alien life, it redefines what life could even look like. As we grapple with these mind-bending possibilities, another question arises. Could advanced civilizations in other universes be searching for us just as we're searching for them? And if so, what tools might they or we use to bridge the gap between realities? This brings us to the next frontier in the search for extraterrestrial intelligence, the role of artificial intelligence. Because if the multiverse is real and life exists in forms we can't yet comprehend, we might need more than human ingenuity to uncover it. We might need the help of machines, not just to analyze data, but to think in ways that transcend our own limitations. And as we explore this idea, we're reminded that the search for alien life isn't just about finding others, it's about pushing the boundaries of what we can imagine and what we can achieve. As we push the boundaries of our search for extraterrestrial intelligence, one tool has emerged as a game changer: artificial intelligence. AI is revolutionizing the way we explore the cosmos, transforming mountains of data into meaningful insights and opening up possibilities that were once unimaginable. From sifting through the faint whispers of distant stars to designing autonomous probes capable of navigating the vastness of space, AI is becoming an indispensable partner in our quest to answer the ultimate question: are we alone? One of the greatest challenges in the search for alien life is the sheer volume of data we collect. Telescopes like the Square Kilometre Array, set to become the world's largest radio telescope, will generate more data in a single day than the entire internet. Sifting through this information manually would be impossible, but AI can analyze it at lightning speed, identifying patterns and anomalies that might otherwise go unnoticed. For example, AI algorithms have already been used to detect fast radio bursts, mysterious, high-energy pulses from deep space that could potentially be signals from an advanced civilization. By automating the search for these subtle clues, AI allows us to explore the cosmos with unprecedented precision and efficiency. But AI's role doesn't stop at data analysis. It's also reshaping how we design and operate space missions. Autonomous probes equipped with AI could one day explore distant worlds without human intervention, making decisions in real time based on what they encounter. Imagine a spacecraft landing on Europa, drilling through its icy crust and analyzing the subsurface ocean for signs of life, all while sending data back to Earth. These AI-driven missions could venture into environments too dangerous or distant for humans, expanding our reach into the cosmos and increasing the chances of making a groundbreaking discovery. Yet, as we harness the power of AI, we must also grapple with its ethical implications. What happens if an AI-driven mission discovers life or even intelligence without human oversight? How do we ensure that these machines act in ways that align with our values and priorities? These questions highlight the delicate balance between innovation and responsibility, reminding us that the search for alien life isn't just a scientific endeavor, it's a deeply human one. This brings us to another intriguing possibility. Could AI help us detect not just life but visitors from beyond our world? Throughout history, there have been countless reports of UFOs, unidentified flying objects that defy explanation. While many of these sightings can be attributed to natural phenomena or human-made technology, a small percentage remain unexplained. Could some of these mysterious objects be evidence of alien visitors? And if so, how might AI play a role in uncovering the truth? As we ponder these questions, we're reminded that the search for alien life isn't just about looking outward, it's also about looking inward. The tools we create, the questions we ask, and the discoveries we make all reflect our own curiosity, creativity, and desire to connect with the cosmos. And as we continue to explore, we might just find that the answers we're seeking are closer than we ever imagined. This leads us to the next fact, where we'll explore the enduring mystery of UFOs and the tantalizing possibility that alien life has already visited Earth. Because sometimes the most extraordinary discoveries are right in front of us if only we know where to look. For decades, the skies have been filled with stories of strange lights, mysterious objects, and encounters that defy explanation. These unidentified flying objects, or UFOs, have captured the public's imagination, becoming a cultural phenomenon that blurs the line between science and speculation. From the infamous Roswell incident of 1947 to the countless eyewitness accounts that followed, UFOs have sparked debates, inspired movies, and even shaped government policies. But in recent years, the conversation has taken a dramatic turn. With the declassification of military footage and official acknowledgements of unexplained aerial phenomena, the search for evidence of UFOs has moved from the fringes of conspiracy theories into the realm of serious scientific inquiry. One of the most significant moments in this shift came in 2017, when the New York Times published a report revealing that the U.S. Department of Defense had been secretly studying UFOs through a program called the Advanced Aerospace Threat Identification Program, or ATIP. Alongside the report, the Pentagon released declassified videos showing encounters between military pilots and objects exhibiting flight capabilities far beyond anything known to human technology. These objects, often referred to as UAPs, unidentified aerial phenomena, move at incredible speeds, make sharp turns without slowing down, and seem to defy the laws of physics as we understand them. For many, these revelations were a wake-up call. If even the military couldn't explain what they were seeing, could these objects be evidence of extraterrestrial technology? The renewed interest in UFOs has brought with it a wave of scientific scrutiny. Organizations like NASA and independent researchers are now taking a closer look at these phenomena, applying rigorous methods to separate fact from fiction. But the challenge is immense. The vast majority of UFO sightings can be explained by natural or human-made causes, whether balloons, drones, atmospheric anomalies, or even optical illusions. The trick lies in identifying the small percentage of cases that remain unexplained, the ones that might hold the key to something extraordinary. This process requires not just advanced technology, but a shift in how we approach the unknown, moving from skepticism to open-minded curiosity. At the same time, the cultural impact of UFOs cannot be overstated. They've become a symbol of humanity's fascination with the unknown, reflecting our deepest hopes and fears about what might lie beyond Earth. For some, UFOs represent the possibility of contact with an advanced civilization, offering a glimpse into a future where humanity is no longer alone. For others, they embody the mysteries of the cosmos, reminding us of how much we still have to learn. This duality between scientific inquiry and cultural myth makes UFOs a uniquely compelling topic, one that bridges the gap between hard evidence and the human imagination. Yet, as we delve deeper into the mysteries of UFOs, we're also forced to confront a more profound question. What does our fascination with these phenomena say about us? Are we searching for evidence of alien life, or are we seeking to understand our own place in the universe? The possibility of extraterrestrial contact forces us to reevaluate our assumptions about life, intelligence, and the nature of existence itself. It challenges us to think beyond the boundaries of our planet, to imagine a cosmos filled with possibilities we've yet to comprehend. This brings us to the final fact, where we'll explore the ultimate question: what does the search for alien life mean for humanity? Are we on the brink of a discovery that could redefine our understanding of existence, or are we destined to remain a solitary species in a vast and silent universe? As we near the end of this journey, one thing is clear: the search for answers is as much about looking outward as it is about looking inward, reminding us that the greatest mysteries of the cosmos might lie not in the stars but within ourselves. As we reach the final fact in our exploration, it's time to step back and reflect on what all of this means, not just for science, but for humanity itself. The discovery of alien life, whether microbial or intelligent, would be one of the most transformative moments in our history. It would challenge our understanding of who we are, where we come from, and our place in the cosmos. But beyond the scientific revelations, such a discovery would have profound social, cultural, and even philosophical implications. How would we, as a species, react to knowing we're not alone? Would it unite us or deepen our divisions? And what might we learn from a civilization that has potentially existed for millions, or even billions of years longer than ours? History offers some clues. When humanity has faced moments of profound change, like the Copernican revolution, which revealed Earth wasn't the center of the universe, or the discovery of DNA, which unlocked the secrets of life, our collective worldview shifted dramatically. The discovery of alien life would likely have an even greater impact, forcing us to confront questions we've only ever pondered in science fiction. Are we unique, or just one of countless civilizations scattered across the stars? Would the realization of our cosmic insignificance humble us or inspire us to strive for greater achievements? The answers to these questions would shape not just our future, but how we see ourselves in the grand tapestry of existence. One of the most immediate effects of such a discovery could be a newfound sense of unity. Faced with the knowledge that we're part of something far larger than our planet, humanity might set aside its differences and come together in a shared quest for understanding. Imagine a world where nations collaborate not just for scientific exploration, but to prepare for the possibility of contact with an alien civilization. The challenges of interstellar communication, deciphering alien languages, and navigating the ethical dilemmas of first contact could become a unifying force, rallying humanity around a common purpose. In this scenario, the discovery of alien life wouldn't just expand our horizons, it could help us become the best versions of ourselves. But there's another side to this coin. The revelation of alien life could also deepen existing divides, sparking fear, mistrust, or even conflict. History shows us that encounters with the unknown often provoke anxiety, and the idea of a civilization far more advanced than ours could trigger existential dread. Would some see alien life as a threat while others embrace it as an opportunity? How would governments, religions, and cultures around the world respond to such a discovery? These questions highlight the delicate balance between curiosity and caution, reminding us that the search for alien life isn't just about science, it's about navigating the complexities of human nature. And then there's the potential for learning. If we were to make contact with an advanced alien civilization, the exchange of knowledge could be nothing short of revolutionary. Imagine gaining insights into technologies that harness energy from stars, or medical breakthroughs that extend life far beyond our current limits. Perhaps we'd learn new ways of thinking, new philosophies, or even new forms of art and expression. The cultural and intellectual exchange between civilizations could propel humanity into a new era of progress, transforming our societies in ways we can't yet imagine. But this also raises a critical question. Would we be ready to handle such knowledge responsibly, or would it overwhelm us? As we reflect on these possibilities, it's worth revisiting the key insights from our journey through these 20 facts. From the vastness of the cosmos to the resilience of life in extreme environments, from the mysteries of rogue planets to the tantalizing search for technosignatures, we've explored the many facets of the search for extraterrestrial intelligence. Each fact has revealed a piece of the puzzle, deepening our understanding of the universe and our place within it. And while we may not yet have definitive answers, the questions themselves have already transformed us. They've pushed us to look beyond our planet, to dream of what might lie beyond the stars, and to consider what it means to be part of a universe that's so much larger than ourselves. In the end, the search for alien life is about more than finding answers. It's about the journey itself. It's about curiosity, wonder, and the unshakable belief that the universe holds secrets waiting to be uncovered. Whether we're alone or surrounded by countless civilizations, the act of searching reminds us of our shared humanity, our shared curiosity, and our shared hope for the future. And as we continue to explore, we're reminded that the greatest discoveries often begin with a simple question: are we alone? The answer, whatever it may be, will change us forever. But one thing is certain: our journey to find it has already made us dreamers, explorers, and pioneers of the cosmos. And perhaps in that sense, the search itself is the most profound discovery of all.